Understanding the Cisco Adaptive Security Appliance Firewall. The Cisco Adaptive Security Appliance Firewall is one of the most widely used firewalls in the industry. It has replaced the older PIX firewall. It has added some advanced modular features over the older PIX firewall and has added advanced intrusion detection and prevention features and a more sophisticated application layer inspection. Configuring the ASA firewall. After logging into the ASA firewall, you will see a prompt that is similar to a Cisco firewall. If you are not authorized to be in this XYZ Hawaii network device, log out immediately. The banner serves a legal purpose. Without the banner demanding authorization, it may not be illegal for hackers to access the network. You will see the prompt type help or question mark for a list of available commands after a successful logon. This shows you are in user mode, not privileged mode. To enter privileged mode, you must enter the proper command and then the correct password. After entering privileged mode, you can enter configuration mode. To do this, you enter the same command as on a Cisco router. Configure terminal or configure T. Once you have done this, you will notice that the firewall uses access lists to filter traffic. To view these access lists, enter the command show run access list. Using configuration and risk analysis tools for firewalls and routers. One of the best websites for finding configuration benchmarks and configuration assessment tools is the Center for Internet Security, run by Cisco. Here you will find configuration benchmarks. Benchmarks are industry standards for best configuration practices. CIS offers a useful tool called Configuration Assessment Tool. This is faster than manually reviewing benchmarks. CAT is available on Nix and Windows systems. A useful commercial tool is Red Seal. It is a unique network risk analysis and mapping tool that identifies configuration vulnerabilities in routers and firewalls. It also generates professional-looking reports. It analyzes intrusion prevention systems and operating system vulnerability scans. Red Seal then shows a graphical representation of vulnerabilities discovered. Here is an excellent example of a Red Seal network risk map. It is a nice addition to a report for visual users. Understanding intrusion detection and prevention systems. IDSs monitor network devices. This allows security administrators to identify attacks in progress and stop them. The IDS examines traffic and compares it with known exploits in a manner that is similar to how antivirus software works. Intrusion prevention systems are similar to IDSs, but they take steps to prevent intrusion. Network-based and host-based IDSs and IPSs. Network-based IDS and IPS tools monitor activity on network segments. They observe traffic and alert a security admin when something suspicious occurs. Host-based IDSs and IPS tools protect critical network servers and/or database servers. The software is installed directly onto the server you are trying to protect. IDSs are characterized by how they react when they detect suspicious behavior. There are two main types: passive and active systems. Passive systems do not take preventative action. They simply alert and log suspicious activity. Active systems, on the other hand, also log activity and send alerts, but they can work jointly with routers and firewalls. Because systems can be compromised in milliseconds, vendors have started focusing on IPSs. Network-based IPSs are installed inline to network infrastructure This means that traffic must pass through the IPS before going into or out of the network. This makes the IPS more capable of stopping malicious traffic. Host-based IPSs operate at the OS or kernel level, so they intercept traffic that is not allowed by the host policy. The anomaly-based IDS uses a baseline of normal activity and sends an alert if the activity deviates from that normal activity baseline. Most IDS and IPS solutions have anomaly detection capabilities. In this chart, we can see some common intrusion detection and prevention systems. McAfee's network prevention system is a network-based IDS IPS with anomaly detection capabilities. Snort is a popular open source network-based IDS, while Cisco's SourceFire is an enterprise Snort-based IDS and IPS. Symantec's Endpoint Protection is a host-based IPS with a network-based IDS as a subscription service. Web filtering. Attackers commonly target devices that are allowed access to the internet. If they can get a user to visit a fake website or install malware from an email attachment, they don't need to break through a firewall. Once this code is installed, hackers can control the Trojan remotely with commands that might appear to be normal traffic. They can then run network scans from this compromised computer and steal data. Web filtering is used to detect users' attempts to access malicious websites and block them. Some web filtering services block malicious code before it gets to a user's workstation, while some block it before it connects to an attacker's control system. Cybercriminals will try to hack busy websites to infect thousands of visitors. These types of large-scale compromises are used to initiate drive-by downloads. Website visitors don't realize that they are downloading malicious code. Security Operations Center, SOC. A Security Operations Center is a permanent team whose members are responsible for security response functions. One function of an SOC is monitoring for indicators of compromise. These are artifacts left behind by attackers which indicate that a system or network has been compromised. Security, information, and event management tools help SOC units identify attacks and indicators of compromise by collecting, aggregating, and correlating log and alert data. Understanding honeypots. A honeypot is a computer placed on the network perimeter that contains information and data and lures and traps hackers. A honeypot is configured to have vulnerabilities. The main goal of a honeypot is to distract hackers from attacking legitimate network resources. They keep hackers connected long enough so they can be traced back. A honeypot is an excellent data collector and an early warning system. How honeypots work. A honeypot looks like it has important and sensitive data on it. An example would be fake financial data. Hackers then waste their time on the honeypot and stop looking for real vulnerabilities. The SOC can then collect data on the attacker. Another type of honeypot, growing in popularity, is a virtual honeypot. It is created using programming language instead of having to dedicate a powerful server to the job. Summary. Network protection systems include routers, firewalls, IDSs, IPSs, web filters, etc. Routers use access lists to accept or deny traffic. Firewalls can be hardware devices or software installed on computer systems. Use NAT, packet filtering, access control lists, stateful packet inspection, and application layer inspection. DMZ. A DMZ is a small network containing resources that sits between the internet and internal network. Intrusion detection systems monitor network traffic. Network-based intrusion detection systems monitor activity on network segments. Host-based IDSs protect a critical network server or database server. Passive IDSs don't take any action or prevent an activity from continuing to occur. Active IDSs log, send alerts, and interpolate with routers and firewalls. Intrusion prevention systems, IPSs, detect malicious activity and can block or prevent malicious activity. Configuring routers and firewall security is easier with benchmark tools. Web filtering can block websites containing malicious codes. Large organizations might need a security incident response team. Honeypots lure attackers away from legitimate resources.